just kind of say your name, current position, and company, and I will kick it off with Megan.
Hi, everyone. I am Megan Toney-Bolger. I am a managing engineer at Exponent. We are a scientific and engineering consulting firm.
Great. Bryson, if you want to go next.
For sure. Hi, everyone. I'm Bryson Nakamura. I'm the Director of Integrative Sport Performance with the Milwaukee Brewers.
Hi, I'm Howard Hillstrom. I direct the Motion Analysis Laboratory at Hospital for Special Surgery in New York City.
Hi, I'm Laurel Kuxhous. I am a program director for the Biomechanics and Mechanobiology program at the National Science Foundation.
Hi, I'm Maria Pasquale. I'm the Director of Application Development with Novell Electronics. We are a pressure and force measurement technology.
Hi, everyone. I am Chantel Murnahan, and I'm the Director of Whitespace Labs. Whitespace Labs is our internal R&D and innovation arm at Lululemon.
Great. Thank you so much, everyone. I think a really great general question to start with that hopefully some of the audience can identify with is if you could give us a little bit of an idea of what your academic path was, if you were involved in any sort of research, and what kind of made you think that industry was a good path for you. So Megan, I'm going to have you start with this one since you're first on the list.
Sure. So I came to my current position straight out of my PhD, which I completed at Georgia Tech, where I studied individuals with amputations and how they adapt to novel walking environments. I ended up in industry, was my intention from the start. I didn't really ever consider a path through academia, largely because I felt like industry would offer a faster pace and kind of the a more urgency that I being a bit of a self-driver, not that academics isn't self-driving, but it was something that I knew I needed, and I knew I wanted to have kind of external deadlines and have a pace that was a little bit faster. So I was looking for industry opportunities, and I kind of fell upon Exponent and was really drawn to it because the dynamic nature of the work and every day being very different, and being able to tap into not only my research experience, but many different areas of expertise and background that I could draw on to apply on a daily basis to my work.
Great, thanks so much. Bryson, I would be curious to hear your answer too, especially as you guys are going through. One of the questions I've always been really curious about is how you found kind of your PhD work and the specific project that you were working on in grad school, and if it needed direct applicability when you were going into industry. So I guess, Bryson, you're a good person to talk about if you did baseball research when you were in graduate school, or if that's something you kind of jumped to in your industry position.
Yeah, for sure. It was actually a really windy road. I actually did no baseball research in any of my background before kind of getting into Major League Baseball. I did play for a small D3 school, baseball, and through that in my undergrad got into biomechanics research, more in footwear product design kind of aspects. And then when I went to grad school at the University of Oregon, my primary research was focused on building classification algorithms using surface EMG for lower extremity powered prosthetics. But I always maintained that interest when I was doing my undergrad. Originally, I was looking to go to physical therapy school. And so, having this balance of being data driven in kind of a rehab kind of mindset and applicability towards helping others was really at the forefront, and merging a little bit of my playing background with the research and with the application of data melded well to fortunately had an opportunity to intern during my PhD with the Tampa Bay Rays, and then once I finished that, moved over to the Milwaukee Brewers. So it's kind of a little bit of a windy road there.
Yeah, that's great. And just a follow-up question, with all of the experience that you had in kind of biomechanics and working with prosthesis stuff, did you feel that the transition was pretty easy and that you had the skill set to jump over, or was there kind of a big adjustment period when you made that switch?
Yeah, for sure. So I think with regards to the actual skill set and tools, I think, a lot of us would agree that we can learn a lot of different things, as we use tools to answer different questions. And so I felt when I came into the position with the Brewers and into a new department here, I really drew from each one of those different aspects. I think we always jump into a position of thinking, oh, I could have done a little bit more. I wish I had a little bit more of this. But, having that broad experience, I think allows you to draw from different perspectives. For example, through all that work at Oregon, I also did some of our performance and physiology based, clinic work and all that. So drawing from multiple different areas, I think is key. And for me, something I definitely relay to students or people that are aspiring to get into sports science from our perspective is that just having that broad perspective and experiences will be beneficial moving into a new position.
Yeah, great. And Howard, I guess kind of a similar question for you. So as Andrew mentioned at the beginning, you obviously are in a situation where you are a little bit more tied to academia than a typical industry position. Was clinical research something that you had kind of done throughout your academic career, so that transition was kind of a more natural one, or were you in stuff that was maybe more basic science and it was more of a switch?
I would say I have done both, basic science and applied clinical biomechanics and biomedical engineering. My doctorate's in biomedical engineering. I didn't realize I'm a kindred spirit there with Bryson, because my dissertation was in myoelectrically controlled above knee prostheses using spatial pattern recognition. And I learned a lot about prototyping, design, development, signal processing, control theory, human subject research. So really, I view the PhD process as one where you get to kind of learn the tools of your trade. How do you form a good hypothesis and all of those things? In my professional life as director of the Motion Analysis Lab at HSS, we're both a musculoskeletal health science center that specializes in orthopedics and rheumatology, but we also have a research division, and we also value education highly. So, for example, internally, there are we have an appointment and promotion committee, and you can be an instructor or an assistant, associate, or full scientist, which is analogous to a professor. And you can write grants internally, externally, and publish and do all the things that you can do in academia. But we're not a degree granting institution, so we're not a university. We're a allied health science center, a medical center, and we're responsible for training the next batch of residents and fellows that are going to become the next surgeons and physicians in orthopedics and rheumatology. But we still mentor everybody from high school science fair students through postdocs. And I'll give you a little glimpse of my bookshelf here. All those hardcover black, brown, and blue books, those are all the poor doctoral students I've trained and master's students I've trained that had to be tortured by me. And that is the fun part of my day. So yeah, we are really a blend of academia and hospital.
Yeah, so when you were looking at this kind of position, was there something that drew you to it where maybe there were a couple cons about academia that doesn't necessarily cross over into the clinical environment, where you knew that it was kind of the best fit for what you were looking for?
Well, I was an associate professor at Temple University in Philadelphia, which wasn't too far from my alma mater where I did my doctorate at Drexel. But when the opportunity came to direct this lab at HSS, we were rated by our peers #1 in orthopedics in the country. The facilities are outstanding. The scientists are outstanding. There are many laboratories at a basic and clinical applied science level throughout the institution. It was a chance to work with top shelf physicians and physical therapists and so forth that would really help accelerate the kind of applied biomechanical work I do in osteoarthritis. So for me, it was a no-brainer when this opportunity came up.
Yeah, absolutely. That's really cool to hear about. Laurel, I want to shift it over to you because I think I can speak for almost all of the students in the room that we're all very familiar with NSF, whether it's through fellowship applications or hearing about our PIs apply to grants. Were you aware kind of career opportunities there during your PhD or during grad school, and how did you kind of find a position there and learn about those?
Yeah, that's a good question. And, you know, I feel obligated to throw in the disclaimer. I feel a little out of place on this non-academic panel because I am still an academic. NSF has this wonderful program where you can come to NSF to work as a program director kind of while you're on leave from your academic institution. So I just finished year one of what could be a maximum of 4 years serving the community as a program director. How I came to it and how it was kind of on my radar, I mean, the National Science Foundation has been on my radar since I was an undergraduate student. So I always knew that someone had to make it run. It was kind of on my longer term career vision, and I spent the 2018-19 academic year on sabbatical, actually on Capitol Hill doing science policy, because I always kind of wanted to know how that worked, and I wanted to know if I liked that kind of work. So I was in the DC area, there was this opportunity, and I know enough not to turn down a good opportunity when it presents itself. So I got to stay in the DC area at least until the lockdown. And so that's kind of how I came to it.
Yeah, and I guess just kind of a side question with that as well. You'd mentioned that this is more of a kind of temporary thing where you go on leave from academia. Are there positions that you think would be a good fit for biomechanics students that are permanent within the NSF? And if so, could you give everyone kind of an idea about what those look like and yeah, kind of where they recruit from too?
Yeah, so thing one to know is that not all program directors are temporary. There's about a 50-50 split between rotators, as we're called, and permanent NSF employees at the program director level. And those are usually mid-career on up people. But there are certainly some options for earlier careers at NSF, coming in as something called an analyst, whether it's a science analyst or an engineering analyst or a program analyst, is a common starting point at NSF for students who have PhDs in all sorts of disciplines, including biomechanics. You can come into those positions whether you have the exact right scientific background or just one that's close, because what matters is that you know how to think about science. And there's also a pathway into NSF and other government agencies through the AAAS fellowship program, where it's the American Association for the Advancement of Sciences Science and Technology Policy Fellowship is popular for people from straight out of school up through retirees. It's kind of an entryway into federal agency work that's a little bit different of a path to come in on.
Okay, very cool. Yeah, I'm personally was not aware of all of the different routes that you could take within the NSF, so hopefully there's some other students on this call learning something too. I'm going to jump to Maria. So obviously, hopefully a lot of people recognize Novell because they're one of the sponsors for the conference. And Maria, it would be great to hear kind of how you ended up going to Novell from your academic path, and specifically like what made you think you wanted to go into industry, because this is obviously a very industry-centric position in comparison to some of the other panelists.
Yes, so I had worked in a sports medicine orthopedics research lab as an undergrad, and I was a bioengineering student. And at that time, which I won't date myself to tell you how long ago it was, but that was only the second year of bioengineering degree was going to graduate in the university that I was at. And the sports medicine orthopedics lab really needed an engineer in some of what they were doing. And so that's kind of how I fell into that position. And I didn't really have a traditional path in the bioengineering because I really didn't work with the bioengineering labs. I worked with this sports medicine lab that was really physical therapists and athletic trainers and sports medicine professionals. And it was a little bit different experience for me. But with that, being the engineer, I got to work with all of the technology. And so I was troubleshooting the technology. I was programming the applications, finding bugs in the programs, and doing all of that kind of thing. And I found that interesting and intriguing, and I made good contacts were providing the technology that I worked with. And in fact, one of the technology companies asked if I would be interested in considering working for them, and that's how I kind of fell into that path. So I started with them as a support engineer, and worked for them for a couple of years, and then moved over to Novell with that similar type of position. And that was 14, almost 15 years ago now, and then kind of moved up and into a more application development position. And really having that background, I mean, the research I did in graduate school was on shoulder biomechanics, which is not really what Novell does right now, but just in general, understanding the research process and understanding technology, how technologies work together, really, I think, allows us to have a unique perspective on how someone doing research is going to utilize our technology and how that's going to all fit together to make them successful in whatever it is they're trying to look at. Novell is a small company, so that's not the only thing that I do throughout the day. I mean, I'm also doing marketing and other fun stuff that I never would have thought that I had the background to do. And that's kind of a on-the-job learning and experience type of thing. But that really makes things exciting because not every day is the same.
Yeah, and the way that you got into it, I think, to me, sounds like one of the more accessible ways to grad students is getting to know companies through troubleshooting phone calls and getting to know people on that side. So I was curious, do you have any advice for students who maybe are working with a piece of equipment from a company that they would be interested in working for, about how to make connections from the student side, or now that you're on the industry side, maybe looking at any students that have done the same and have any recommendations for people on that?
Yeah, I mean, I really think in our field, I was saying this to Karen, Troy, who was on this call before we started, is we're a real friendly group. Everybody enjoys working with each other. ASB offers incredible opportunities for networking and for mentorship and other things like that. Utilize that to the best of your ability. Introduce yourself to people, reach out to people, find out who knows who, and network. I think that's the best, and I think this group is really great at promoting that and also accepting that, and that everyone is also very open to it and friendly.
Great. And then I'm going to jump to our last panelist to kind of answer similar questions. So Chantal, I think you're a really cool panelist to see on here, because I think a lot of people are obviously familiar with Lululemon, but maybe not quite as much with what you guys do on the biomechanics side that a lot of students on this call could probably jump into or would be really interested in. So was your background in, kind of sports performance that led you into this kind of role, or how did you end up at Lululemon in the biomechanics area?
I had zero intention of going into industry my entire academic career, so I'll start there. But I started with a master's in biomechanics, and my research was really focused on fall prevention and really the mechanics underlying postural control and balance. I started to get really, really fascinated by neurophysiology and started to work on motor unit recordings kind of on the side during my master's with Dr. Parveen Bawa, and started looking at motor unit rotation in muscles. And then I really merged the two and did a PhD in neuromechanics, and the focus was continuing along the path of postural control and balance, but focusing more on the neural control of postural control. So my PhD was all about exploring the nature of postural sway, why we sway, and looking into the mechanisms underlying that. I decided that I needed to really differentiate myself in this space, and I ended up moving to do my postdoctoral research with Dr. Stephen Scott, and that was in the Center for Neuroscience, and it was more so doing cortical recordings in monkeys and looking at how different areas of the brain respond to mechanical perturbations of the limb. If anybody's heard of the kin arm, looking at those neural recordings. During that time, I actually got pregnant with my first son. So I'll bring the personal conversation into this a little bit because it was a really pivotal moment in the trajectory of my career. I planned on staying in my postdoc for 2 years and ended up returning to Vancouver on my maternity leave because my husband had stayed in Vancouver. And during that time, I had full intentions of continuing my postdoc. I had collected an insane amount of data, planned on doing data analysis and publishing. And he was very supportive of that. And I just decided, I ended up starting consulting for Lululemon, actually. Planned on doing it very, very short term. I was teaching and had planned on taking an academic position at a college university in the area. And I fell in love, to be honest. The area that I'm in, we have biomechanists definitely on our team. And like I said, my background is more what I like to call neuromechanics. And that kind of blending was always a huge focus for my boss. So my boss, Dr. Toney-Bolger, has a PhD in sport technology and engineering from Loughborough University. And his philosophy was really about bringing all different types of minds together and looking at problems in a really critical manner where you're looking at them from a biomechanical perspective, a neuroscience perspective, a psychological perspective, and really looking at problems in a completely different way and starting to think completely differently about what those solutions could be. So fell in love with Lululemon and ended up staying on full time. And I've been with Lululemon now 6 years, coming in August.
Awesome. That is a great answer. And before, I know Andrew said 20 to 30 minutes here. We have a question in the chat that seems to be getting quite a bit of attention that I think everyone would love to hear from all of the panelists on your opinion. So someone chimed in and said that they have a master's in Mechie with some experience in industry and biomechanics. But as they're kind of going through the job application process, it seems like a lot of jobs in the biomechanics area, whether it be in kind of a clinical position all the way over to a very typical industry job, require or strongly encourage a PhD to some extent. So would you guys be able to comment kind of within each of your roles, you know, what may be open to bachelor students and master students and PhD, and if there is kind of a hard cutoff on what jobs are available with those degrees?
I'll go first, only because I think I'm the only master's level person on this panel. Correct me if I'm wrong there. But I will say it was not required for the job that I had applied for at the time. And I think the entry level position that I came into, it wasn't required at that time. Again, that was quite some time ago now. I am a big proponent of experience means a lot. And also diversifying yourself means a lot. I think Bryson was mentioning that a little bit as well. So going through an undergrad and a master's and a PhD and a postdoc and working on one very small portion of one little thing is very admirable and needed in research and in the scientific community, but diversifying yourself also gives you a lot of experience. And so I think that's something to be considered when you're thinking about where you want to end and where you want to, you know, transition.
Should I go next, I guess?
Yeah, sure, Howard.
At HSS, there's a position, there's 6,500 people that work there, and they're trained at all levels. And in terms of research and laboratories, we're the motion analysis lab. Above us is the biomechanics lab, next to the orthotics and prosthetics center, across the street from the soft tissue lab, blah, blah, blah. So there's many labs, and you could have a wide variety of backgrounds and degree levels, whether it's engineering or biomechanics or more genetics or something else. If you want to direct a lab, you should probably have a PhD. But if you want to work in a lab, you need not have a PhD. If you're obviously applying for a postdoctoral fellowship, that means you have a PhD. But there's people at every level, and some of them are career people that stay at maybe with a bachelor's level, and they wind up being a research coordinator or something like that, or a technician for collecting data or analyzing data, and or have a master's, and it could be in engineering, it could be in kinesiology, it could be in a wide range of disciplines. So there's no hard and fast rule, that you are limited with any degree. It's like there is positions that are appropriate for each level of training.
Yeah, great. Bryson, do you want to chime in here and kind of give everyone an idea of what it looks like at the Brewers?
Yeah, for sure. And kind of combining Howard's and Maria's comments, I echo them both. I think that, going back to what Howard said earlier, like the grad school pathway gives you some of those tools and experiences to learn how to apply towards questions. But at the end of the day, if you can ask great questions, if you have the tools to go and solve it and the desire to go and fight through a lot of tough times, really, you're going to get a chance. And so, especially for us, the degree is simply something that gives us some barometer of where you're at. But a lot of our positions are open to bachelor's, master's, PhD, just kind of across the board. In fact, really just being a good human being in the sense of coming in, working with a team, working across departments, being humble in the fact that we're a piece of this puzzle here for, in our sense, building a world caliber team, and then having that mindset to push forward and drive forward, and the tool set to ask great questions. And none of that is necessarily dependent on having said degree.
Mm-hmm.
Yeah, and I'll just chime in quickly. I know we're coming to the end, Jenny, but I feel like I've been hanging back here. So
please chime in.
I just wanted to chime in and say, so I echo everything everyone is saying. I really think that having the PhD and having kind of those letters after you are an indicator of the training that you've had, but certainly aren't an indicator of, your value being above someone else's. I really agree with Maria and what Bryson has said specifically about experience being one of the most important things. And some of the skills that I know are most important, at least in our industry, are in the consulting world is, communication, technical skills and problem solving, being a self-driver, and being able to work in teams. And those things are not mutually exclusive for a certain degree. And those are certainly things that whatever level of degree, whatever level of education you're at, you can really cultivate and try to demonstrate when you go on the job market, because those are the soft skills that aren't necessarily evident or apparent based on the degree that you have.
I'll just add one other thing from my perspective, because we do speak a lot about being T-shaped in our team. And I think that idea is that you have deep expertise, but you have really strong range that can be applied across a lot of different concepts, across a lot of different collaborations, across understanding the business, which is in and of itself a skill that has to be learned or experienced on the job. So I think that T-shaped analogy really lands for me in how I start to think about kind of the needs when we move into industry with a particular expertise.
Yeah, great. And Laurel, I know, I was going to say you're the one that hasn't chimed in yet. If you want to chime in before we wrap it up.
Chime in on this one. There are certainly opportunities to work as a scientist, broadly speaking, in government without having a PhD. They're going to be different jobs, but for example, the FDA hires a lot of master's level engineers to work in their Center for Devices and Radiological Health. The thing that's probably the most important to know as you're looking for government jobs is if it's at an agency and it's a job posted on USA Jobs, read the qualifications carefully. If it says you need a doctorate degree and you don't have one, don't even bother applying, because those requirements are very strict within the government. So look for something that has requirements that you meet. Yeah, great. And then before we kind of break out here, I just wanted to
give you guys one question that maybe you can start the breakout rooms with. That seems to be a really common one going on in the group chat here. I think there's a lot of people, especially with the influence of COVID time, who are curious with each of your different positions, kind of when the best time relative to your graduation is to start looking at those. So I think it would be really great if when we break out, you guys could touch on how important it is to make a connection early, or if the job application and hiring process tends to be pretty rapid and when students should start looking at that. So I will echo Andrew's comments here as you guys are breaking out, that if you don't have a number in front of your name, please do, and I will hand it back to him.
Okay, and with that, I'll start the breakout rooms, and I'd like to thank all the panelists again for taking part in this. And in the breakout rooms, please ask questions, interact with the panelists. It's really supposed to be an informal and interactive process. So you should all receive invitations to the breakout room, so if you join them, you can get started.
Hey, Andrew.
Hello. How are you?
Hey, was this the one that you still need me to hang out at the end for, or is Jenny covering that?
If either of you have a preference, I don't, like if one of you want to go to the breakout sessions, that's fine with me.
Yeah, no, I mean, I'll go to the breakout session. I just meant like when it gets closer to 4 o'clock, you need somebody to stay?
Yeah, I will need somebody to stay. That'd
Okay.
be great.
Cool.
Mary, do you know where I placed you?
I think you placed me in number 2 in professional sports originally. I just wanted to be put in clinical, or the clinical laboratories with Howard.
Wait, so hold on. So I placed you in 3, but you want to go to 2, or I placed you in 2 and you want to go to 3?
You placed me in 2, and I want to go to 3. There you go.
Okay. Okay, if you rejoin a breakout room, you should be in 3. Sorry about that.
No worries. Thanks.
Maura, did I assign you to the wrong room?
No, you didn't, but I changed my mind. So would I be able to go to 2?
Okay, where are you coming from? Was it 6?
I came from 3.
Okay.
Yeah, sorry. Just thought I'd make it really complicated for you.
Coming from 3, okay. Done. So if you join the breakout room, you should be.
Okay.
Rebecca came from 3. Jenny, were you interested in any of the breakout rooms, or? Hold on, Rebecca, I'm working on it. Though I don't see you in 3.
Would it be easier if I left the meeting and came back?
Yeah, I think so. Sorry about that.
Okay. That's okay.
Okay, Rebecca, you should be good now. Sorry about that.
Got it. Thanks so much.